So students, let's talk a little bit about Chapter 8 on Copernicus. As a reminder, these videos are for help. They're not going to be a substitute for reading the material in the chapters. Alright, so Copernicus, sort of in the 1500s, reintroduced the ideas of Aristarchus, that the sun was at the center of Earth's motion, that Earth orbited the sun, and that the Earth rotated around its own axis as it orbited the sun. So the Earth had two motions, a yearly or annual motion around the sun, and a daily or diurnal motion around its own axis. Now, what Copernicus also had in his theory was that Mercury, Venus, Mars, Jupiter, and Saturn also all went around the sun like Earth. So this is the first time in which we can say Mercury, Venus, Mars, Jupiter, and Saturn have something in common with Earth. They all go around the sun, and Earth has something in common with them. So this is the first point where we can refer to Mercury, Venus, Earth, Mars, Jupiter, and Saturn as planets in the modern sense of the word, right? Because those worlds could have something in common with Earth, and Earth could have something in common with those worlds. Now, Copernicus's theory had a very nice explanation for the retrograde motion of the wandering stars, or planets as they would be under his system. The explanation was very simple. The explanation Copernicus had for retrograde motion was that the planets actually did not undergo a retrograde motion. In fact, Earth constantly circled around the sun, Mars constantly circled around the sun, Jupiter constantly circled around the sun, slower, Saturn circled around the sun, it was the slowest of the batch, Mercury is the fastest, then Venus, and so forth. And that the retrograde motion was actually an illusion that came about because Earth's going around the sun faster than Mars is. Mars is going slower. So this means that every so often Earth is going to lap Mars as the two are going around the sun. Earth is going around more rapidly. So Earth is periodically going to lap Mars, pass it up. When it laps Mars, when it passes Mars, the fact that it's moving quicker than Mars is going to give the illusion that Mars is going backwards. Think about you're driving in a car down the road, and there's a car ahead of you that you're gaining on. You can tell that that car is going forward down the road, and you're going forward down the road. But as you actually pass the car up, you get this impression that the car is actually moving backwards by comparison to you. And then later on you look in the rearview mirror and you can see that car's following you down the road. So you get this momentary appearance of backward motion. This also happens when you are closest to that car, okay? And it happens when Earth is closest to Mars as the two orbits. So as Earth passes by Mars, it's at its closest point to Mars. So that explains why Mars is always the brightest when it's undergoing the retrograde motion, because we're passing it, and it's just over in the next lane. So that's why Mars looks brighter. Also, since Earth is passing between the Sun and Mars, that explains why the Sun, Earth, and Mars are all in a line. So that Mars is on one side of us and the Sun is on the other. So the Copernican theory explains why you have that alignment between Earth, Mars, and the Sun whenever Mars is in retrograde motion. It also explains, for example, why Mars goes through retrograde motion less often than Jupiter, and Jupiter does it less often than Saturn. And that's because Mars is the faster of those three planets. Mars is the fastest. So we don't lap it as often. It takes us longer to catch up. Whereas Saturn's the slow one. We lap Saturn pretty regularly, almost once a year, a little bit more, because Saturn's so slow. So we lap Saturn more often, it retrogrades more frequently. We lap Mars less often, it retrogrades less frequency. So the Copernican theory did a really nice job of explaining all of the motions of the wandering stars, or planets as we would call them, under his theory. So, nice theory. Copernicus was worried about a few things. First of all, of course, all the same old objections against the heliocentric theory that were present with Aristarchus are still present with Copernicus. If we're rotating, we're moving so fast, how come we can't detect it? Okay, Copernicus could of course say, well, it's the common motion, everything's moving together. What powers this big heavy ball of rock around the sun? Not a good answer for that at all. And then what about the parallax problem? And then you have to say, well, the stars have to be really, really far away, so we don't see the parallax issue. Another thing that by Copernicus's time that had come up that was not present in Aristarchus's time is that the culture was Europe, and it was Christian, and there's a number of places in the Bible that reference the sun's motion. Okay, so there's a reference to the sun rises, and then the sun sets, and then it hastens back to its place of rising, and to do it over again. There's someplace else that refers to the sun rising like a giant coming out of his tent and running his course. Okay. Those definitely give the idea that the sun is moving. Now you could argue and say, no, look, that's just written to describe how we see things, and that's not supposed to be a description of the actual motions of the heavens. Nonetheless, Copernicus was a little bit worried about that, and made mention of it in his book. So anyhow, it's a cool theory. The question is it right? And that's what we're going to get into on our next chapter.